What's up, guys? We're going to be exploiting some vulnerable jQuery. This one is a little bit of a rabbit hole, so hopefully you'll stay with us for the ride. We're going to be using this lab. It's a type of DOM-based cross-site scripting attack, and it's based around a hashchange event. Now, we'll explain everything after we fire up the lab. Initially, we're going to focus on the intended functionality of the code here. So we just have a regular blog style page with different posts. And the first thing we'll do is check out the page source. We already have a clue. We know there's going to be some vulnerable jQuery in this vulnerability. At the bottom of our source, we have script tags and we see some jQuery. Generally, we recognize jQuery because it's prefixed by this $sign. So this is the jQuery selector. It's selecting the window and it's listening for a hashchange event. Now, the first obvious question is, what is a hashchange event? When we think about the way that a URL works, it's possible to have a hashtag at the end of the URL to pass data to the page. This is very commonly used for bookmarking, and this is in fact the intended functionality of this. So assuming the value following the hash changes, then a JavaScript function is called. So it's going to take the value following the hash. So we could just set this to hash123 for now. As you can see, it doesn't make any difference to the page itself, but it will trigger this particular JavaScript function. Let's take a look at what this function does. It creates a variable called post, and it's going to assign to the result of another jQuery selector. So let's interpret this jQuery. We have the $sign. We then have section.bloglist. Now, this refers to the HTML elements in the DOM. Notice we have section with a class of bloglist. Within that section of the document, it's then looking for a h2 element. And notice it's making use of a contains method. And what this contains method does is search for a h2 element that contains the string that's provided as an argument for that contains method. So in this case, what is it passing as the search string for the contains method argument? Well, we've terminated our JavaScript string temporarily, and we are concatenating the results of a JavaScript function. And that function is URL decoding the string. Which string? Well, the string that's found in window.location.hash.slice. In other words, it's looking at the string starting with the hashtag. Now, you might wonder about that .slice, why specifically .slice. If you return to our page where we've set the hash value to 123, we can access that with window.location.hash. So that returns hash123. So as you can see, window.location.hash actually returns the full hash value, including the hash character. We're not really interested in the hash character itself, which is why we can make use of .slice. Now, what .slice is doing is essentially treating that string like an array, and it's starting from index 1 onwards. It's slicing out of the array anything that appears before index 1 in the array. So as you can see, window.location.hash.slice with the argument 1 just provides the value following the hash. So nothing too complicated there. So we get a feel for what our JavaScript is doing. It's looking for the h2 element that contains the value following the hash in the URL. Once it's got that element, it's then calling scroll into view. So it's saying if the element exists, if post, then it's calling post.get 0 scroll into view. So the idea is that jQuery is returning a jQuery object. We can then call the .get method on that object, provide an index number, and it will select a certain element. You see, sometimes jQuery selectors return multiple elements, a collection of elements, so we need to reference them by their index number. In this case, we're only going to return one element, so we're calling post.get on index 0. Then we're calling the .scroll into view method. So just to see an example of what this is doing, let's find a h2 tag. For example, we have a h2 tag that contains the text procrastination. Let's head back to our page and let's change our hash value to procrastination. Let's press enter. As you can see, the page automatically scrolls to that h2 element. In other words, it's being used as a type of HTML bookmark. We change the hash value, the page then jumps to the h2 element that contains that search string. Now, this is where things get kind of interesting, because although the page itself is not that secure, there is also a vulnerability with jQuery at work. You've probably figured out by now to some extent that we have control over the argument that's passed to this jQuery contains method. In other words, when we change the value of the hash, we are also changing the argument that's passed to this jQuery contains method. The idea with a jQuery selector, however, is that it should return an element from the page. So we might assume that we can't really inject anything here. We could change the search term by means of the hash in the URL, and we could select a different element from the DOM as a result, but it's unclear how we can actually inject something into this h2 contains method. And it's a vulnerability with the way that jQuery works. It has been patched at the time of making this content, but you will still find some outdated jQuery versions in the wild. Let's take a look at the jQuery vulnerability itself. So first, I'd like you to just notice some of the logic in this code. So we have a jQuery selector, and the value of that is being assigned to a post variable. The next stage of the logic is to check if that post variable actually exists. So the idea behind this logic is that if the selector doesn't return anything, then the value of post is going to be undefined because nothing is returned from the jQuery selector. Sounds logical, right? But that's not actually how jQuery works, as we'll go on to see. Let's take a look in the console. So in the console here, we are going to call that jQuery selector function, but we're obviously going to hard code the variable as procrastination. So we know this should obtain a match. And the result here is a jQuery object representing the selector. And you can see it has a length property of 1. In other words, it's saying this jQuery selector has one match, and we can expose the DOM element by calling the .get method. So if we assign this to a variable, let's say var post equals, and assign that to our jQuery selector, as is in the JavaScript in our vulnerable lab, we can then call post.get. We can provide the index of 0 because the jQuery search only has a length of 1. And when we call that, now we see the DOM element exposed. Now that's fine because we know that particular DOM element exists. So now let's try with a search term that we don't think exists. So we've deleted one of the letters from procrastination. We're going to assign the results to post. And of course, this is just a statement, so it will return undefined. But when we take a look at that post variable, we see that although this doesn't have any matches, it still returns an object. It returns that jQuery search object. It just has a length of 0. So you can hopefully sense that something is not quite right with the code in the lab, because remember that code is based around this post variable not existing, assuming the jQuery selector doesn't return any matches. Whereas we can very clearly see that it exists. If we were to do if post, which is the type of logic used in the JavaScript, so we'll say if this exists, we're going to console log out true. And you can see we console log out true because post obviously exists. If we console log out the inverse of that, we say if post doesn't exist, console log true, we don't get true echoed to the screen. So obviously, as an aside here, we can see that the fictional developer of this vulnerable lab doesn't fully appreciate how jQuery works. It's returning that jQuery search object regardless of whether there are any matches. So checking to see if post exists doesn't make any sense. Now, this is not really a big deal. It doesn't cause the vulnerability directly, because if we call post.get on index 0, obviously we get undefined, And that's because that jQuery search object has a length of 0. In other words, there's no element matched here. So it doesn't really matter if we call scroll into view, it's not going to do anything because the element doesn't exist. We just get an error. It doesn't break the page. It doesn't necessarily cause any security issues. So the question is, where is the vulnerability? And it's if we take that contains method and we start trying to include tags. So rather than input procrastination, let's see what happens if we input a h1 tag. Now, if you check out the jQuery documents, it's very clear. It says that this argument is supposed to be a string. It's not supposed to contain tags, but this is what creates the vulnerability. So let's see what we get as a result. Let's check out that post variable. And we appear to have a match. Now, that can't really be possible because there is no h1 tag with this arbitrary text on the page. So why is the jQuery object indicating that there is a match when we run the contains method? Furthermore, that jQuery object has a length of 1, which means that we can expose the DOM element with post.getIndex0, and we get a h1 element, and it contains our arbitrary text. In other words, this contains method has actually created a DOM element. Now, the next question is it on the page anywhere? And the answer is no. And we can check out the properties of this DOM object. One thing we can do, for example, is have a look at the parent element null. In other words, this is a detached DOM element. It's been created, but it's not attached to the page so far. Having said that, this is a valid DOM element. So I'm going to reassign post to post.get at index 0. In other words, post is now our DOM element. And just to prove that this is a fully functional DOM element that's just not currently attached to the DOM, let's attach it to the DOM. Let's give it a parent node. If we take a look at the source code, we're just looking for an ID that we can trigger off. So we have this div ID equals Academy Lab header. So returning to our console, we can say my node. So we'll say var my node equals document.getElementById. So this is just vanilla JavaScript. We can select a DOM element based on its ID. So we'll look for my Academy header. Let's see if we can get the ID correctly there. So it's Academy Lab header. Let's try that one more time. Academy Lab header. Let's check out my node. And notice we have a DOM node here. So what we can do is we can append a child to that node. So we can say my node.append child, and then we can pass in the element that's been created by jQuery, which really shouldn't have been created. So we're calling my node.append child post. Let's take a look at our page. Notice we have now appended that created element to the page. So the first stage in understanding this vulnerability is, although that contains method should really just be a search function, it should just search the existing DOM, we can see that if we inject tags rather than a legitimate string, jQuery is actually creating a DOM node in the background. And it's this that causes the vulnerability. Now, we don't have a vulnerability yet. jQuery creates a DOM node, so what? Well, there's something that you should know about DOM nodes that have a source tag. Take something like an image element, for example. It has a source attribute. And based on that source attribute, it makes a HTTP request to grab the image data. So let's create a new element making use of vanilla JavaScript. So we're going to say let my image equals create element, and all we need to do is pass image as a string. And of course, it needs to be document.createElement, since this is a method that lives in the document object. Let's run that. Let's check out my image. Once again, you're probably familiar with recognizing what DOM nodes look like. This is an image tag. Now it's just a blank image at the moment. We want to set a source attribute on this image element. So this is really straightforward. We can just reference our DOM node, myimage.source, and we can simply set our source. Now I'm going to set it as 0. So 0 as the source is something that's going to error out. And notice what happens when we do this. A HTTP request has been created. In fact, if we had errors turned on, you would see that we're getting a 404. So immediately, when we set the source attribute on our newly created image element, a subsequent HTTP request has been sent looking for that image. Take a look at this URL. It's got our lab URL /0. It's looking for the image at that location, 0. We get an error. Now this is despite the fact that this image element is not attached to the DOM. As soon as we add that source attribute, the browser sends that HTTP request. It gets a 404 error because obviously that image doesn't actually exist. Hopefully you can see where we're going with this. Although we can't exploit this jQuery vulnerability to actually append an element to the DOM, we can create a detached image element which creates a subsequent HTTP request. Then, when it receives a 404 response because the image invariably doesn't exist, we could trigger some JavaScript to launch on error once we get that 404 back from the server. Let's see if we can do that. So returning now to our jQuery, which essentially allows us to generate an arbitrary element just detached from the DOM. Well, we don't want a h1 this time. What we actually want is image source equals, and we'll use double quotes because we're inside single quotes at the moment. We don't want them to interfere with each other. Source equals 0. That's going to error out because it doesn't exist. On error equals, and we are going to call the alert function. Now the goal of this lab is to call the print function, but we'll get there shortly. Let's see what happens if we create this element. And let's turn on errors because hopefully we'll see this error out. So this should create an image with a source of 0. As we've seen, when a DOM element with a source attribute is created, an immediate HTTP request should be sent. Let's see what happens here. Nothing happens at the moment. That's because we didn't close our image tag. So let's close our image tag. So now we have a proper DOM element. And you can see HTTP request sent. Also, alert popped up to the page. So what we've done here, we've created an image element, not attached to the DOM, but the point is it has a source attribute, which then triggers that HTTP request. We get an error back because that image doesn't exist. Normally it will be a 404. We've got a gateway timeout 504 right now. That's probably because my session with the lab has expired at this stage, but we get a 404 back and we get on error attribute executed, which is our JavaScript alert function. So I've just refreshed the lab session there just so you can see it is actually a 404 error we get if we are still connected to the session, and you can see we get the same response, which is that JavaScript alert executed. Now we've done this through the console. Just so you know, you can also do this with the hashtag. So for example, if we pass hashtag image source equals 0 on error equals alert, we'll get the same cross-site scripting attack reflected to the page. Let's run that. So you can see in the background, jQuery is calling that contains method. It's creating a new DOM element with a source attribute, which creates a HTTP request. The result of that is a 404, which then triggers our JavaScript in the onError attribute. Okay, we understand the mechanics of how the exploit works. We just need to deliver the exploit. You see, right now, this is basically self cross-site scripting. In other words, we're arbitrarily changing the value of the hash. The user is obviously not going to do that for themselves. We need this exploit to be automated. And what that means is the user's browser needs to be changing that hashtag with JavaScript so that the browser gets that on hashchange event and then executes the JavaScript. And one of the obvious ways of doing that is by an iframe. And it's going to be an iframe that changes the hash value after loading. So the user will get the regular page in the iframe. Once that's finished loading, the JavaScript will then change the value of that hash in response to the iframe loading. Let's take a quick look at how this works. And we're going to go to the built-in exploit server. So here is a rough idea of what this HTML snippet will look like. It's an iframe. It has the source with the URL of our current lab, just with a hashtag at the end. Then, in response to the iframe loading, we'll say this.source, so we can reference our own attribute here with this.source plus equals. So we're going to take the original source stem and append to it the value that follows the equals inside the single quotes here. That is going to be image source equals 0. On error equals print. Now, the reason why we are using print instead of alert is because this is the objective of the lab. It's to call the JavaScript print function, not the alert function. So same logic, we're just calling print instead of alert. Now, we have a few options here. We can deliver the exploit to the victim, but the first thing we like to do is see if this actually works. So we can pretend we are the victim and view the exploit. So if I click here, you can see we get the print JavaScript function called, which, as you can see, brings up a print pop-up window asking us to print the page. So that clearly works. Let's head back to our exploit lab. The only remaining step now is to deliver this to the victim. So we'll choose the option deliver exploit to victim. Let's give that a moment. Congratulations, you solved the lab. So the reason why I described this as a rabbit hole at the outset is really that there are a number of issues which coincide to generate this specific vulnerability. So problem number one is the fact that the developer is allowing the user to manipulate the value of the hashtag manually and therefore control the argument that's passed to the jQuery contains method. That's problem number one. Users shouldn't be able to provide arbitrary values to our scripts. Problem number two is a vulnerability in the jQuery contains method. Obviously, it's supposed to return a jQuery search object with a length property indicating how many matches there are to that search query. But you can see if you inject tags into that contains method, we can actually manipulate that contains method into creating a DOM element. So that's problem number two, is a vulnerability in jQuery, which has been patched. But as mentioned, there could still be some old versions of jQuery in the wild which are susceptible to this vulnerability. Problem number three, and this is really more of a feature than a bug, when we use vanilla JavaScript to create a DOM element with a source attribute, it immediately dispatches a HTTP request looking for that image. And it's really this specific functionality that finalizes the exploit, because without that functionality, we just have an arbitrary DOM node which is not attached to anything. It's the fact that when we apply a source attribute to a DOM element, that it dispatches that HTTP request that makes the entire exploit possible. Thanks very much for watching, guys. Hopefully you learned a little bit about jQuery, and especially hopefully you learned about DOM cross-site scripting and how we can manipulate the DOM using vanilla JavaScript.